I've been around for a while. The first 15 years of my career spanned a revolution in web development. Using the Common Gateway interface to program a website, it gave you almost nothing. It's just like, oh, here's your URL, build a web page. Java servlets was already like the first big improvement of that in introducing an inversion of control where the framework said, no, we'll call your code when it's time to do a web page. But also having a framework that ran the other, that was opinionated as it ran your code, saying, make your code fit our framework and trust us, things will be better, and it was. Things continued this way with important framework features being added. Django included them all, did them really well, added a few innovations of its own. And I was at the first DjangoCon in 2008. And by that time, I felt like this had been the evolution in our tools. Like being a web developer in 2003 was having your ass hang out in the air, and being a web developer in 15 years later was so much safer, protected, supported. And there's so many more metaphors I could use. Another one I've got later on is the idea of working in a chaotic, messy workshop versus one that's organized with your models over here and your views over there. Just changed. It made us all like 10 times more productive. Then in 2020, jump forward, I was working on an HR startup, and we were importing lots of customer HR data to our production database through a pipeline, and then ultimately to our production database, because we needed copies of people's salaries, job grades, managers, teams, job levels, and much more information, their bonuses, their commissions, to bring into our system and be able to do analytics in our system. And it was such a mess. We started building framework code just as we were going, trying to manage our own chaos as we went. And I can't stop thinking about this. I left that company 2 years ago, but I couldn't stop thinking about what a mess it was and how it brought me back to this pre-framework sense of what a mess. Where's the guidance? Where are the utilities? Why are there several different ways of checking if something's afloat throughout our code? And a framework is not just a library that you can do tactical things. Like Pandas is fantastic, but it's extremely tactical. You need to know what you want to do in a spot and tell it to do that. That's great. Libraries are great. But a framework puts you into a structure of doing things a better way and from a foundation that you don't have to build as much. And it can be quite opinionated, which I like. I like that a new member can join the team, and if they've done Django before, they figure it out. And often there's a more declarative style too, like the way Django models declare model attributes rather than make them methods. I also can't stop thinking now, even now that I'm no longer put on the data engineering hat, what the work conditions are like, having your ass hanging out in the air. So I've started working on this. And with a great friend, Jeff Koleski, we've been building a framework, not a library. This isn't what we built in the last startup. We started from scratch, and we started from a developer experience perspective. We started from what should the code exactly look like? Specifically for somebody in a position of doing this kind of pipeline. There's some data. It could be more structured than this. It could be just a CSV. And repeatedly, like every week or every day, or when notified by WebSockets, you run the same pipeline on fresh data and bring it into a data model that you know you need to end up with. And I want to apply these Django concepts to the developer in that position and see how far we can get to help developers in that position have better jobs. So this is the core of the vision, building from the developer experience. What should be the developer experience of writing that list of steps that is going to be applied every week or every day or every hour to slightly changing or greatly changing data? I would like the steps to be so declarative and so clear that they're this readable. That was the core, the kernel of what turned from a library into a framework. And one of those steps, any one of those steps, should be this easy to define. If you have to write a custom step because you're doing something that is unique to the data you're working with, you should be able to write a method, put it where you like in your code, and the only thing you have to do for the framework is to decorate the step and tell the framework, this is a row step. You're going to need to give this step data row by row. Great, the framework can do that. I like pandas for some things, but it can be very unreadable when the next developer comes. So I wanted to encourage pandas steps to be wrapped in a step name, be given a purpose. When you have to name a method, you're also often forced as a developer to give it a purpose. So we're calculating the hour average here. We're not, the mean is the important part of this step, not the group by. That's a means to the end. Haha. And encourage documentation and encourage testing of these specific things. So, I mean, even when you look at a unit test for something that is a few lines of pandas wrapped in a method name, now the unit tests are additional documentation as well as making sure you don't change what it does by accident. And speaking of tests, steps should be this testable. You should be able to just cons up a tiny little bit of data, not your whole data file. You shouldn't have to go through hoops just to get data to give to your test, to give to your step to test it. You should be able to give the step just what it needs because steps should be targeted like that. That makes a step like this much more reusable. I could reuse combine full name in any data source that had FN and LN, and who cares if it has employee ID or not. We also, Jeff and I, built some built-in steps for common problems. You can check if a field is unique when you get a data file. You can drop duplicates. You can filter rows you do want or don't want. And for dealing with structured data, when there's substructure in a field like location, having lat and long, you can flatten that if you need to. And that works for even things nested several layers deep if you've got some JSON record data. But a lot of common tasks that you want to do are type and value oriented. They're not even transformations really so much as casting and renaming. A whole lot of work gets done in a messy data pipeline, renaming columns and making sure you didn't import the wrong column because things got offset. So make sure the minimum value is 0 or 18 and the maximum value is 100 or 2,000, whatever, applying those kinds of things. We thought that should be done declaratively. And again, it's a lot like declaring in models attributes. Being able to say what the name of the column ought to be after the column transformations are done, which allows you to rename from a number of different names. If Carta calls it one thing and Fathom calls it another thing, you import both of those, but it's fundamentally the same field, so you can rename them to the same thing with the same declaration. So now these things are magic. These things are one line of declarative code that often does several things in one line. Like I've got each thing separated into a different example, but you can both have the date column with the date time format to cast it, but also give it a minimum or a maximum value to make sure you don't have the wrong date column by accident. And it should just be magic to fix column names and values with spaces around them or capitalization differences. I didn't even have an example for that because the column class just does it. All right. I've dived into the details of steps and columns, but the framework wraps those in two more concepts, which is a phase and a pipeline. The pipeline handles opening files, pulling data out. It could also handle streams if somebody were to contribute that. And passes data to phases. The phases runs the column logic, runs the step logic, and changes the shape of the data for each step as it needs it. And there's some nice debugging outcomes of that choice we made. But another important choice, and again, this was driven by writing the first code we wrote, wasn't functional, wasn't working code, it was prototype code of what would this look like if we had written this to be a great developer experience. And so we were driven by this vision of having a chunk of code that says, we're going to do the blood glucose calculation in this phase, so we can give it a name, and we can tell it which columns it needs, and we can give it its steps. And at the end, we've done a useful chunk of work, and it's extremely readable. Now, a phase doesn't have to be that small, but it's often useful to at least break up some parts of your pipeline. It really helps narrow down the problem. And in our pipeline, in our complicated HR data pipeline, we built, this is the real prototype of the phase part of Phaser, is that we broke our pipeline into several different steps, including checkpoint files, so that we could look at the data in between steps and see and debug problems very quickly. And we were trying to get the data towards a common internal format that wasn't even database ready, but it was getting closer to database ready. So the final transforms we tended to need to do before it was ready for the database would work for all of our sources. And we ended up having a lot of code that we could use between those phases, could reuse it. It's modular. It's amazing. So that means a phase is a lot like a Django model, because the list of columns is very like a field, like a list of fields in a Django model. The way it collects, it marshals the work for the steps is very like the way a model handles query sets and things like that. The way we wanted to be inspired also by the way it handles exceptions, which I'll get you. So this list of things I wanted to be inspired by, we've only checked off one thing so far, but it was the big one, the core, the logic, the real, I don't know, the core. I have no other words for it. But there's a bunch of other things that I want to move through a little more quickly, because getting inspiration from Django for these other things was also really useful. Run tools. I love these in Django. I make great use of them, and started to build some run tools in Phaser, so that although you could trigger a pipeline from code that doesn't, you could trigger it from code that is like a Django view that triggers a Phaser pipeline through a button in the admin code. You can also run it with run tools, which is especially useful when you're developing and debugging. And we could use some more run tools if Phaser grows and gets adopted. We wanted to have exceptional exception handling. The magic that you get when you don't even have to handle a does not exist error because it just does the right thing, that kind of magic can be reproduced in a pipeline. There are certain errors where if it's an error, you can just drop the row. That's the right thing to do. Like if it's not one of the employee statuses we're looking for, you can just drop the row. Oh, and one tip, hot tip, hoarding is terrible if you work on data. You can always go back to older versions, earlier versions, and get what you dropped. Drop early, drop eagerly, drop that data. You have less to work with and less bugs later on if you drop your data early and eagerly. But there are also cases where you find an error that's so bad you want to stop the pipeline and like notify the developer. So being able to handle different things with good exception types was important. Utilities are so important to get consistent in this kind of project. We've got a contributor who said in her biotech data team, every time she joins a team in her domain, which is seriously this biostatistics and data gathering in preparation for research and drug development, she says every team I join has 11 different ways of loading and saving CSVs. That's appalling. Having strong utilities that are suited for this purpose is a big benefit. But it's also good to have ways to do things like row numbering. The Phaser will throw row numbers onto the columns, onto the rows as it's working with, and then we'll remove them at the end if you don't want them. But they're there in the checkpoints for debugging and seeing the difference between the data you expected and the data you ended up with. Oh wait, we're missing rows between 7 and 13. I wonder if something happened to drop those rows. Unified handling of null and nan values. The number of bugs I've seen where nans or nulls or nuns were handled differently, and that was the source of the bug. Oh, PTSD around that. I did try Django import export when we were building all of this in my last startup, and I liked it a lot, and we continued to use it, but I ended up stealing some ideas for it and moving more and more code out of it. So Phaser ended up being the phases that we built in that startup were the first thing to run until it was ready for Django import export, and then Django import export would bring it into the database. But I was so inspired by Django import export's really powerful diff tool that I outright copied it and had to write a CSV differ for that, which somebody might find useful, now you know about it, to do things like diff the column names. Which isn't a native thing you can do, unless you know you're diffing CSVs and have an idea for what could have changed. Okay, so now we've been inspired by a lot more of the great parts of Django. The last two things are extensibility models and where your stuff goes. It's actually surprisingly extensible, although we've done very little work to explicitly be extensible. It's actually surprisingly extensible already because of being object-oriented. If you define your own columns, if you define your own phases, then you override the behavior you need to override. And the ability to just define new columns ought to handle a lot of desire for extensibility. And the whole point is to define your own steps. Even if 90% can be handled with one-liner, built-ins, column declarations, and magic, the remaining 10% is important to your business or your project. We have a few of the answers for where stuff goes, but only a few. We know where we have conventions for where pipelines go and for where output goes, working data, the checkpoints between phases so that they can be diffed when you want to see what happened. And we could use conventions for where tests goes. So this is on my list of things to do. And that's gotten us most of the way through our list of some of my favorite things in Django that ought to feel the same when you're developing a data pipeline. We have a few other ideas. We have an issues list, and not even everything we want to do is on the issues list. And I'm sure if we had more activity, people would have even more ideas about what it could do. But I know I'm running short on time. So what I hope we've accomplished here, I hope that you have been reminded how nice it is to start a new Django project or to come to a Django project that's new to you, but you know where to find those models and views. I don't know if it's possible to convey how messy web development was in 2003, but try to imagine it. And enjoy that feeling of gratitude for a moment. Because although we're engineers, we know things can always be better. I do like to look back and think how much better things have become. If you have data engineers in your company, I know a lot of them are super junior in their career. Data engineer is often treated in companies as a place where you land, and then as soon as you actually know some software architecture, whoop, you can be a backend engineer now. And so the data engineering code base suffers from every single contributor is inexperienced, and then they get moved on over time. So that's a big flaw in some companies' data pipelines as a result of the way they're managing their engineers. And I'd love to be involved in building better ideas, although I also would love to see frameworks for data engineers go into other languages and other frameworks. If you know people working on beautiful soup, I think it's great. But I think it could be a framework. And other languages like R. R is powerful, but surely we can do better than R with some modern thinking there. So I think there's a huge potential for this, and I welcome people's thoughts on that. Maybe we help this guy out a bit. The link to this presentation and Phaser and other things can be found via that. I'm easy to find online, Lisa Dusseault. You only have to spell my last name right. That's the intelligence test. Low pass filter. High pass filter. Any questions?
The QR code is taking you to a page, it's a sheet that's protected Yeah.
Of course, I didn't test that. Well, hang on to that, and in 5 minutes, I'll make it world visible.
Cool. All right. Any other questions for Lisa? Okay.
I like your T-shirt, by the way.
Oh, thank you. I was going to ask who's going to finally win the browser war, Mosaic or Netscape, but I was wondering if you had. So, I'm not a data engineer. I have a data team of brilliant data scientists I work with, and they've settled on a tool called Apache Airflow for doing some of these types of things. And I was wondering if you looked at any of the existing tools and what their shortcomings might have been that led you to develop something like Phaser.
I looked at a lot of them, and I looked at them repeatedly. I looked at them at the start of our startup, and whether we should start out with something like Airflow, and I looked at DBT and Dagster. I looked at them halfway through, like 2 years have passed, 3 years have passed. I am now hiring data engineers. I should look at this stuff again. I looked at them again starting Phaser. And I think you do need those tools. Sometimes it's going to be a yes and. I don't know what the answer would be if you wanted to take something like the structure and framework that I'm trying to give with Phaser, but then run it in an Airflow environment because you need the queuing management system that Airflow gives you to keep all of your many high volume data flows moving, which that would be a whole thing you'd have to write that's definitely not part of Phaser. Can those two be married? Maybe, but I think they solve different problems.
I also just wanted to say that Phaser is an absolutely awesome name. Pew pew.
I always use Star Trek characters in my data for tests.
Yeah, I appreciated the Deep Space Nine references for sure. Yeah, we still got more time, and if there are any other questions for Lisa.
Thank you. I noticed in your dependency graph that you have, I think, 6 people who are dependent on Phaser. Do you know if anyone's using Phaser in production or using it in any of their workflows right now?
I don't think so, but if they, but I should take a look at that. I didn't know about that tool.
It's in the community tab.
Yeah.
All right, well, let's give Lisa a hand and